In the previous session, we have looked at the series for e to the power of x given by the infinite series x to the power of n by n factorial. Now, by substituting different values for x, let's figure out some derived series. So, if x is greater than 0, which is our standard, this one, we would have 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, which is what e to the power of x is for positive x. Now, if we have a negative x, then we have alternating series with an additional factor of minus 1 to the power of n. Now, if x equal to 1, then we have e series 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. Now, if x equal to minus 1, then again we have the series e but with alternating signs. So 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and so on. Now let's look at a very interesting composition of e to the power of x and e to the power of minus x. So let's figure out what this series looks like. E to the power of x plus e to the power of minus x divided by 2. So adding the series expansions of e to the power of x and e to the power of minus x, we get the series of e to the power of x plus the series for e to the power of minus x. Now combining them, what happens? 1 plus 1 equal to 2, x by 1 factorial, they cancel out. X square by 2 factorial, x square by 2 factorial becomes 2 times x square by 2 factorial. Again, x cube by 3 factorial and x cube by 3 factorial cancel out. Similarly, we get 2 times x to the power of even power by even power factorial. Now 2 is common to all of them. So we take it out and take it to the left hand side. We get e to the power of x plus e to the power of minus x divided by 2 is equal to 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus x to the power of 6 by 6 factorial and so on. Or we get the series x to the power of 2n by 2n factorial. If we have done composition in terms of addition, let's look at subtraction. E to the power of x minus e to the power of minus x divided by 2. Subtracting the series expansions for e to the power of x and e to the power of minus x, we get 1 minus 1 plus minus times minus plus. So we have 2 times x by 1 factorial plus 2 times x cube by 3 factorial plus 2 times x to the power of 5 by 5 factorial and so on. Again, 2 is common to all of them. We take it out and take it to the left hand side. And we end up with a series of odd powers with the denominators as odd factorials. Now, let's take x equal to 1 in e to the power of x plus e to the power of minus x by 2 expansion. We get e plus e to the power of minus 1 divided by 2 is equal to 1 plus 1 by 2 factorial plus 1 by 4 factorial plus 1 by 6 factorial and so on. Now let's take x equal to 1 in e to the power of x minus e to the power of minus x by 2. We get e minus e to the power of minus 1 by 2 equal to 1 plus 1 by 3 factorial plus 1 by 5 factorial plus 1 by 7 factorial and so on. Now, let's look at this in a slightly different way and look at 2 more series. We have series n equal to r to infinity of 1 by n minus r factorial, where r is a positive integer and n is greater than or equal to r. So here if we expand this, we get 1 plus 1 by 1 factorial plus 1 by 2 factorial and so on, which we recognize as the expansion for E. So that means this is equal to E. Here remember, n is starting with r. So it will start with r minus r factorial. That is 0 factorial. That is 1. So 1 by 1, 1. Then we will have r plus 1 minus r. So 1 by 1 factorial and so on. Now what about the series 1 by n plus r factorial? This was n minus r factorial. So here we know E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. But let's figure out some additional terms from r minus 1 factorial. So we have 1 minus r minus 1 factorial plus 1 by r factorial plus 1 by r plus 1 factorial plus 1 by r plus 2 factorial and so on. Now here we are going to split it into two. The finite series up to 1 by r minus 1 factorial. And the rest we will take it as the tail series. And this finite series of initial terms, we take it to the other side. So we end up with E minus this initial terms is equal to the tail. By the way, this tail is nothing but 1 by n plus r factorial. So which means the series 1 by n plus r factorial is equal to E minus the sum of initial terms, which can be written as E minus the summation k equal to 0 to r minus 1 of 1 by k factorial. So if we remove finitely many terms from the exponential series, the series remains convergent, but its sum becomes E minus the finite sum of the removed terms, which is what we have done here. So that was some additional series based on the series e to the power of x. Now, if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.